Hey, everybody. Thank you so much for coming to the Unscripted conference. Today, we're going to be covering Continuous Integration 101. My name is Bryan Feuling. I'm a Solutions Architect at Harness. The goal for this talk is not to get into codes specifically, but really to kind of understand the fundamentals of what continuous integration is. The best way that I could find to do this was to contrast it with the opposite of continuous integration, which is called deferred integration. So we're actually going to walk through kind of what both of those actually mean for a company. This is not also intended to downplay anybody. So if you feel like you want to do continuous integration or you think that you are and you're not doing it, that's totally fine. We're actually going to end this with some actions that need to be taken in order to achieve continuous integration if that's the desire. So who am I? My name is Bryan Feuling. Some people call me Bri-Fi. You can also find me a Sneaky Aneurysm all over the place. I, as said, I'm a solutions architect for Harness. Some of the stuff that I've done in my background is like app dev work, DBA work, sysadmin, automation engineer, and pretty much everything in between. And I've done different talks on and teaching different courses on things like Helm and Kubernetes, GitOps, verified GitOps, CI/CD best practices, things along those lines. So it's a little bit about where I'm coming from. So today we're going to be covering, again, Continuous Integration 101. So to start off, let's go with the official definition of what continuous integration is. So this is a quote from Martin Fowler, one of the fathers of the CI/CD movement, if you will. And he states that it's a software development practice where you have your members of the team, they're actually integrating their work frequently, typically at least once a day. So one of the basic foundational rules of CI or continuous integration is that it has to be done daily. If you're not doing it daily, you're not doing continuous integration. So that's an important thing to note. So because your teams are operating this way on a frequent integration basis, you're actually going to be having multiple integrations per day. Each integration will then be verified with an automated build and testing process so that you can detect integration errors as quickly as possible. Now, the opposite is deferred integration. We're actually going to use an inverted quote of this one from Martin Fowler. So it's a software development practice where your members of your teams actually integrate less frequently or infrequently. So it way more than once a week, probably like 2 or 3 times a week per person, but not getting into the dailies. And so this process will be larger amount of code changes that are going to be going in, and they're going to be verified using manual build processes, manual testing. So you still want to have the outcome of detecting integration errors, but you're going to be doing that through more manual processes. So these are the 2 paths that we're actually going to be following down. Now, to start with, what we want to do to be able to kind of level set between these two is let's use an analogy that actually sets us up, something that we're probably going to be pretty familiar with. It's going to be called the new software engineer analogy. So whether you're the new software engineer or you're hiring a new software engineer, what would it look like for them to build out new feature functionality for an application? So you have the software engineer and they have this idea. It's a grandiose idea. They've done their design spec work that they want to put together, everything like that. They kind of know what they want to put inside of the product. So now they're going to start coding it for us. So the first thing that they are going to need to do is get the main application code. Wherever that lives, it doesn't really matter in this analogy right now, but somehow they need to get the main application code, and then they're going to pull that locally onto their laptop or desktop. And then as a result, once they bring that in, they'll actually start to build their new feature code. Now, you can extend this analogy to troubleshooting or bug fixing or whatever that might look like, but in this case, it's going to be the new feature. So you're taking the main application code that you've locally copied, and you're going to be adding your new feature code, and what you're going to end up with is a larger locally integrated code, right? So this is still living on your box, on your laptop. And so what you're going to do then is you're actually going to build that artifact. This is so that way you can make sure that you can deploy it out as needed. So you're going to build the artifact. A part of that building of the artifact is going to be a testing process. So you're manually or automated, doesn't really matter at this point, but in some way you're going to be testing how your features and functionalities are behaving with when you tie it into the main application code. That's kind of the idea there. The outcome of your test is going to result in some feedback documentation. Right. So again, you're taking the main application code, we're adding our new feature code to it locally, then we're going to be taking that local integrated code and basically building it or compressing it into a build while we're doing testing on that. And then as a result of all of that process, we're going to have some feedback that we're going to want to loop through and fix, right? It's pretty much inevitable that the first time we build new code, we're going to want to fix certain bugs that might show up or things are not showing up the way that we want them to. So we're actually going to loop back through that process of adding the new feature code or updating the new feature code, working through the locally integrated code, running the tests, doing the feedback. And we're going to do that until we have a full successful build and test process where we don't have any more feedback. Now, what's going to be interesting here is we're actually going to re-loop through and grab the newest version of the application code. So wherever you pulled it from originally, there's a chance that it was actually updated since you originally pulled it down and did all your work. So you're going to want to loop back through and grab that new application code, and then you're going to walk through the new feature code process again, and you're going to keep doing that smaller loop until it's successful, and then the bigger loop and the smaller loop till it's successful. And you're going to do this until your bigger loop is successful. And once your bigger loop is successful and you have that all the way through without any changes that are needing to be done, then you're actually going to take your new feature code, you're going to merge that into your main application code where it was living that you went and pulled it from. And then that should run through a build process, kind of like a main production ready build process. And then that will then be compiled to an artifact, and then that artifact will be deposited into an artifact repository or a location for the artifact to live. So this is the analogy that we're going to be walking through and leveraging for comparing and contrasting continuous integration versus deferred integration. But just kind of keep this in mind that there is a local process that needs to happen. Then once the local process happens, then you need to have more of a production ready process that's going to happen. So let's take this into an understanding of how we do this in continuous integration versus deferred integration. So first, we want to see a visual overview. So what we're going to do with the continuous integration process, you have your whole team. In this case, you're going to have one user from that team, but the whole team is going to be committing some form of code back, right? Whether that's, again, feature requests that they're implementing or new functionality or bug fixes or troubleshooting or something along those lines. So the whole team is going to be leveraging this on their own local boxes. And the way they do that is going to be pulling from a repository, typically speaking, a Git repo. I think it's the most popular one right now. There's a few others out there that can handle source code management, but they'll be pulling from the Git repo locally, and they'll actually be working locally, not really in the same way that Git is done, but that'll all happen locally. And then once they take that local amount of code that they've done, both the feature functionality that they're building as well as the main code that they've cloned down from their Git repo, it's going to be running through this automated build process. A part of that is going to be something called unit tests, and then there's also going to be some integration tests. Usually both of those are going to be implemented for a continuous integration process. So we're going to run the unit test, the integration test, and then we're going to have some feedback on that. And then we're just going to basically cycle through that process again. And this is the local perspective of how this is running. And this, again, has to be done daily. So if we go back to the analogy, once we get out of that local loop and everything is working the way we're supposed to, then your team will be committing back to the trunk or the main, so it's trunk-based development or main-based development. So they're going to be committing their local code back to trunk. It will then run in a more of a CI build server. So it's going to be something that is automated based off of main being updated or trunk being updated. That will then run a unit test, integration test, and usually something that's a little bit more expansive than what you had locally. Then that will be giving feedback. If it is not successful, the feedback goes back, obviously, to the user or the team that was building the functionality or feature. They'll go through and fix that as needed. But if it does pass, then it'll go through the whole, build it into an artifact, and then put it into an artifact repository. So that's the daily process, and this is daily for every single person. Now, if we look at this and contrast it with a deferred integration, it's usually a single user at a time. The reason for this is something that anybody who's tried to do a continuous integration internally has fought with, which is called merge conflicts. They can be a massive pain, especially if you are not pulling your main branch down frequently and testing that locally. That can be really painful. So in deferred integration, you usually have one user at a time, or maybe one team at a time that'll be doing one piece at a time of their function or features. They'll grab the code files wherever that locally or that lives, maybe on a network share or something. They'll grab that, pull that in locally or to a local server that their team runs off of, right? So they'll have like a central location for that. Then they'll run through some manual testing. So that'll be, let's compile this code. Let's take a look at how the website looks or the site looks or the app looks and actually do some work there. Let's send some dummy data through it and figure out how that's actually writing back to the database. So some manual testing is going to be in effect. And then we're going to take the output of those manual tests and we're going to be compiling our feedback and then basically reinstituting that feedback into this process. Now, not only are there less steps and a lot of this is not automated, but deferred integration means that you're doing this about weekly, where you're going and pulling the code, you're running the tests, you're doing the feedback process, all that type of stuff. And then you may pull the main code again in a couple days, right? So this is going to be deferred integration process. So that's more of a visual understanding. Now let's walk into a more of a practical perspective of this. So with continuous integration, the first thing to note is the process inherently doesn't require a tool to be able to do a continuous integration process. You don't technically need a CI tool to do it. However, there are so many that exist, vendored and non-vendored, that if you were to build your own tool or build your own process outside of a tool, it's kind of obsolete. It would basically be reinventing the wheel at that point. So highly recommend looking into a tool if you want to implement continuous integration. Now, some of the basic requirements to adopt continuous integration, the first one is you need source code management system, right? You need something that can manage your source code. And it needs to be in a way where you can use, you can basically commit, you can pull, you can merge, you can push, you can do all these different types of things in a programmatic way. So there needs to be an API, there needs to be a CLI of some kind that can integrate with your source code manager. That is going to be a requirement, especially if you want to build out the automation that makes continuous integration possible. The next thing you want to do is have a local or an automated build of a locally developed code base, right? So you take the code, you're putting it into a Git repo. You probably have spun up a new branch, created a new branch of the typically called a fork of what my main is going to be. And then I actually want to do my coding off of that forked branch. And then I'm going to run a locally developed code base build, right? And so I'm going to run my testing through that. Now, assuming all of that works well, I'm going to re-upload that to the main or the trunk. And then that is going to run its own testing on that as well. Now, assuming that's all finished, then we're going to upload that artifact into an artifact repository. And again, this is going to be done every day by every person at least once a day. These are the things that make continuous integration a continuous integration process. If you're not doing it daily, you're not going to have continuous integration, right? If you don't have testing, yes, you can get it to a daily piece, daily cadence, but if you don't have testing on there, it's going to be kind of pointless, right? So you need all of these things to make continuous integration work. Now, how about deferred integration? So deferred integration, honestly, deferred integration has been happening ever since applications were ever developed. You always had to be able to add new code to existing code. It's always been there. Now, a lot of times you'll build your own process around this. Sometimes you'll use your own integration tool. Sometimes companies will use a CI tool or a continuous integration tool, and they'll use it for deferred integration practices, which is fine. The tools are there to be executed whenever you need them to. But it'd be kind of normal to be able to build your own process internally, right? Because deferred integration is going to be based off of how you, your team, and your company operate. So the basic steps or the basic requirements to adopt an SDLC, your source code must be stored somewhere that developers can access. In a lot of cases with deferred integration, this is a local file box. This is a local network share. And then what's going to be happening is that typically that local file share is also going to be on the same server, or I should say the main code. It's going to be on the same server that your build process is going to be on. It's going to be on the same server that your artifact repository will be on. So all of that, you'll just have like an oversized server and all this stuff will live on it. Then you want to be able to test the source code. So that'll be done manually. You'll basically be pulling that down, running the source code manually, testing that. And then once that is finished and you've gone through the iterations of pulling that down from the main server, the finalized artifact will actually be built and then stored back onto that server. So pretty much everything is going to live on that central server outside of your locally developed code. Now, deferred integration, we'll see this with waterfall processes. We'll see this with release parties, companies that are releasing less frequently. So maybe quarterly releases or semi-annual releases. And so this is where the operations team will grab the newest artifact and pull that from, is this local server that was built off of. So that's where deferred integration comes into play. So as you can see, continuous integration is very much around the automated processes, making sure things are repeatable, reliable, and scalable. Deferred integration is more about making things local and not really enforcing a time restraint or restriction on your users internally, right? So you've got these two contrasted perspectives. So there are benefits to both. So let's definitely cover some of those benefits there. So continuous integration, the first benefit that's going to be pretty massive is it's going to allow for that repeatable process that you can iterate upon. So if you want to meet some time to market requirements, if you want to meet security or compliance requirements, if you want to standardize, typically through some type of declarative language process like a YAML or a JSON or something like that, and you want to make these things repeatable, continuous integration, that's a massive benefit for it. Another one is when you're committing at least once a day, you have small changes that are being committed, right? So if you were committing once a week, you're probably looking at maybe a couple hundred lines of code that's changing per commit. Whereas if you're committing at least daily, if not more than once a day, then you're probably seeing about 10 to 20 lines of code changed. So the smaller changes are committed, and they're easier to detect and fix when there are builds that are breaking. Additionally, because the process is inherently repeatable, you actually have engineers who know where they are in that integration process. They can see what's working, what's not working, and they can see if there's any bugs that exist. Because bugs are easier to find and remove when you're making small changes and you're committing small changes to the main line of code at a time, right? So this is a massive, massive benefit to continuous integration. It actually reduces risk, something we'll talk about, but it reduces risk in the entirety of your software delivery or software development lifecycle. Another one that's actually pretty massive that not a lot of companies are leveraging in deferred integration, actually it's near impossible to do in deferred integration, is difference debugging. So it's the idea of saying, I've got this locally built code, and I'm going to stand that up next to my mainline code that exists right now. And I'm going to look at them side by side, and I'm actually want to see the difference between the two. So if I know that there's an error, I can go look at the difference between the two sets, right? My local versus the main, and I can see what the differences would be. So maybe I, fat fingered something, and as a result, I've got a mistype that's in there, right? So this allows me to have a very quick way to debug when I'm doing a difference debugging, and it's really only possible if I'm doing small changes at a time. Then I have testing automation. I can iterate on the testing automation, and I can expand my coverage of my testing automation, and I can consistently improve and increase as my integration process matures. So once I've got my entire team going through an automated continuous integration process, then the team that's associated to the administration portion of that process can actually spend a lot of their time making it better rather than troubleshooting all of the issues that can come into play. And then the last one, and this is actually a pretty massive one, especially for time to market, is that it enables your teams to achieve frequent deployments. This is huge, right? So most companies don't want to do quarterly releases. They don't want to do semi-annual or annual releases anymore. They want to be able to deploy or release very frequently, multiple times a day if possible. It kind of goes back and loops through 1 through 6 again on this continuous integration benefit portion, where we're able to reduce time to market. We're able to meet security requirements, compliance requirements, standardization requirements. We can debug faster. We can have hot fixes that go in. We can meet feature requests. If we have an automated CI or continuous integration process, then my frequency of deployments will actually increase, and I can do way more frequent deployments than what I was doing before. So massive, massive benefit for running through continuous integration. Now, in the case of deferred integration, there's a couple benefits to this one. So the first one is there's a single location for all the source code, and it makes it really easy to work through the build process. And when I say single location, in continuous integration, there's a single location in the sense that it exists in a Git repo or an SVN repo or something like that. With deferred integration, the single location is the main code, the build process, and the artifact repository all live typically on the same server or in the same location. So all of that happens in one spot. I don't have to go to multiple tools or multiple locations to kind of get that information or to make it work through the process, right? So that single location for all of that source code, it actually makes it really easy to work through the build process. If I'm not enforcing a daily build, it allows my developers to move at their own pace. If I've got some developers who are able to commit every day, totally fine. If I have some other developers that maybe they're not comfortable committing every day. Maybe they want to work at it over the course of a couple days or a week. I'm not enforcing a daily build so they can move at their own pace. On top of this, it's kind of backpacking on the last one, I can enable my teams to deploy when they're comfortable, when they're confident, and their manual tests are going through appropriately, and they've got everything run through the way that they need to feel that confidence level. So instead of saying I'm going to deploy every day or multiple times a day because I'm building multiple times a day, instead I can say, hey, work at your own pace, make sure it gets out there, make sure it's good code. And then when you want to deploy and you feel comfortable with all the processes, we've got our QA team in place. We've got all these things that are put together. At that point, you'll feel a lot more comfortable in deploying. So go ahead and deploy. So let's kind of do a sum up of the continuous integration versus deferred integration, really kind of hitting the high level points that we've kind of talked about so far. And then we're going to jump into some action steps. So for continuous integration, the first one, it's defined by executing your integration process at least once a day. So this is continuous integration. If you're not doing it at least once a day, if your teams are not doing their integration process at least once a day, you're not doing continuous integration. Now, that's not to say that you're not doing good practices. That's not to say that you're not a good company or that you're, technically bad. It just means that you're not doing continuous integration based off of definition. So if you want to be full on continuous integration, you need to be doing these things at least once a day. Now, the end goal of continuous integration, it's actually to automate the build and testing process. So if you can automate that entirety of the local and the main or trunk build and test process, and you can expand that and iterate on that, that's kind of the end goal. Right, because now we're reducing the amount of bugs that are showing up in our code. We're reducing the amount of troubleshooting efforts that show up as well, and we're making a significantly less risky deployments, which actually is the next step. So when you're doing those small changes in code, you're reducing risk and you're increasing your deployment frequency. It's another massive benefit of continuous integration. So bugs are also easier to find and resolve when they're smaller. If I have a bug that's showing up because of one line or a half a line of code, that's really, really easy to find and squash. However, if I have 20 bugs that are showing up because I've committed 100 lines of code, it takes me a little bit longer to find out what's going on. And are they bugs that kind of rely on each other, right? So if I'm doing 10 lines of code at a time and I'm seeing 2 bugs, it's pretty easy to see, are these bugs related or are they independent? If I'm doing 100 lines of code and I've got 10 to 20 bugs that are showing up as a result, are they related or not? No idea. I have to kind of walk from top down, left to right to kind of figure out how that is actually supposed to be, how I'm supposed to be fixing the bugs. And do I remove one and it removes 3 without knowing about it? And is that bad for later? So there's a lot of questions that can come in to that process. So trunk or main-based development, it allows more developers to contribute their code more frequently without these massive merge conflicts. Part of that continuous integration process, which we saw in the analogy, is that larger loop where we're going back and pulling down the main code. If everyone is committing frequently and there's small changes, then the amount of work that I need to do once I re-pull the main line of code to test what I've already locally built and run build and tests on, to run through that and pull that main line of code down, it's not really going to be a lot of changes that are going to affect what I'm doing. So it actually means I can commit to main or trunk way faster because I'm not having those merge conflicts. Real quick about merge conflicts, because this is a massive thing to really understand when you're going through it. A merge conflict is when I've got multiple users, multiple developers committing or working on code locally, and then they commit at the same time or near the same time, and they're not pulling the main code down again to test it locally on their box, then one person's code and another person's code may not merge correctly because things are broken, things don't exist anymore. There might be some regression processes. Things along those lines might exist as a result. So the larger amount of code changes that you're committing and trying to merge while another team member is trying to do the same thing, you're going to have massive merge conflicts. So if you can reduce the amount of changes you're doing and you can make sure that you're continuously pulling the main line of code before you commit up just to do a local test and build, you're actually going to reducing a lot of those merge conflicts as well. Your source code management, it's going to have native versioning in it. This is another massive benefit. If something breaks, I can revert the version. It's fine, And I can also do a comparison. Git has a really interesting process called Git blame. So I can see who's made the change and what changes were made. I can always revert back versions if I need to. So I have that native versioning. I also have programmatic interaction capabilities. This is required for automating my continuous integration. I need to be able to run a command or have some type of trigger that auto runs a command for me that pulls down my main line of code. I need to be able to do that. If I'm not doing that, I have to wait for this massive manual process of a click journey. It's really, really annoying, and it actually slows our teams down from production. Now with deferred integration, it's defined by executing the integration process about once a week. And think of the integration process as that larger loop where I'm pulling down the mainline code and working locally off of that mainline code that I've pulled down. I'm really pulling that mainline code maybe once a week. And then once I've pulled that down, then I can run through the rest of that production level integration process as a result, right? So I'm doing that about once a week. The end goal of deferred integration is just to have a successful artifact. That's basically it. I'm not really worried about having automated builds. I'm not worried about having automated testing. I'm not trying to run through this on a daily basis. It's really just about getting to that successful artifact, and that's about it. Developers in deferred integration, they'll have time to build out their features or their functions, and they're not forced to consistently commit. With continuous integration, you'll most likely have these processes where it's like, on file save locally, auto do commit up, and you'll build out this entire git command process that you're going to run through, and you're required to do that on a regular basis, and you're going to have checks and balances and things along those lines. With deferred integration, I'm not going to have any of that. So my teams can work at the pace that they feel most comfortable with. As a result, deployments are infrequent. They're actually only executed when teams feel confident in the build. So when my developers, they give the thumbs up to that artifact, my QA team, my ops team gives a thumbs up to the artifact, that's when I can actually deploy. Centralized code storage, it can live on a network share. It doesn't have to be in source code management. It doesn't have to have versioning. It doesn't have to have any of that stuff if I don't want it to. There are some cases where we do want versioning, but want things in a local network share, so we save it with a version number at the end. I've seen that happen many times. I've had to do that with different files multiple times. So centralized code storage, it can live pretty much wherever you want to. So with all of that, let's actually talk about taking action. So let's say you're looking at this presentation today. Maybe you go back and you rewatch it and try to study and understand what continuous integration actually is and what it looks like. And you want to take that information and then go back and start implementing continuous integration. Why would you want to do that? Well, if you want to decrease your time to market, if you want to decrease risk, if you want to deploy more frequently, if you want to increase the productivity and the input of your developers, in continuous integrations, that's the process you want to pursue. Honestly, there's not really any cases that deferred integration is a good option. It's more of a relic of the way that things had operated for a long time. So continuous integration is where pretty much everybody's going at this time. Again, I don't know of any reason to not go with continuous integration. But if we wanted to implement continuous integration, what 3 steps are required to achieve that? So the first one is you need to have a source code management solution. You have to have one. Git, SVN, it doesn't really matter. It needs to have some basic functionality. You need to be able to version your code. And then you also need to be able to programmatically interface with that source code management solution. Now, this doesn't have to be cloud-based. It doesn't have to be on-prem based. It doesn't have to be one of the main players that are out there. It's really just about the fact that you need a source code management solution. That is step 1. Now, step 2 is you need to be able to design an automated build process. You need to have a build process that works locally, and you need to have a build process that works on like a main CI box, right? Where you're going to be doing your CI process off of the main or the trunk branch. So you need to have a automated build process that just works as soon as that there's a file change. That's a requirement. And then lastly, you need to have an automated testing process. So the testing, it's not just the fact that I'm running a command and, all of a sudden it checks that the server was able to be pinged and I receive a 200 response code. That's not the type of testing. We're talking about unit testing. We're talking about integration testing. I need to be able to smoke test it and load test it. I need to be able to send data to it. I need to make sure I'm pulling data out of it and I can see that the desired response data is there. I want to run security tests on it to make sure that I'm not, there's no SQL injection attacks on there. Or there's no cross-site scripting attacks that are on available for me, right? I want to run some Nessus scans or something along those lines. I also want to be able to do a WebDriver-based test or a UI-based, UX-based test. I want to make sure that the colors look right, that the outcome looks right. I want to run through that whole process, but I want to do it in an automated way. So I need to extend my automation around different tools or different script processes or whatever that might look like, right? So these are the three things that you will need inevitably to get into continuous integration. Source code management that can be interfaced programmatically. You need to have an automated build process. You need to have an automated test process. And once you have these, continue to iterate on how you're implementing them and how your teams are using them. Make it easier for your teams to use. Make it easier for your teams to onboard with, right? And this will actually, as a result, not only create repeatability and reliability, but it'll also add scalability to your operations internally. So thank you so much for joining for this Continuous Integration 101 course. If you have any questions, there's my email, Twitter handle, LinkedIn. If you want to see some of the stuff that I've done on GitHub, you can add that there. And don't forget to follow Unscripted Conference. Thanks.